150? This goes on 150, not 151. There we go. Thank you. Looks like a D. All right, so geometric sequence is a sequence in which the ratio between any two consecutive terms is constant. All right, a sequence in which the ratio between any two consecutive terms is constant. The only difference between this definition and the definition of an arithmetic sequence is this word ratio. Okay, in the arithmetic sequences, it says difference. Okay, because it's a common difference. You're adding, adding, adding. Arithmetic's just a different word for arithmetic. Excuse me. Geometric, it's a ratio because you'll be multiplying, multiplying, multiplying. Okay, so your common ratio is the numerical ratio. And it's said that way because it's not going to be a variable. It's going to be an actual number. It's the numerical ratio between any two terms, where your variable is equal to R. R for ratio, D for difference. So in these first few, we're just going to be asked to determine the common ratio. So there's a difference between determining it when you know it's a geometric sequence and trying to figure out if it is a geometric sequence. So if I'm trying to figure out if it is, and sometimes I know you can just look at them and say, okay, I know I'm multiplying by 3 each time and it's pretty obvious. But when they get to be fractions or some other things, it may not always be quite as obvious as what's happening. So if you want to actually figure out what it is, you can take one term and the term before it. So your R is going to be equal to 24 over 8 and figure out what that is, right? And so you see that you are multiplying by 3. And then, so if you know it's a geometric sequence, that's enough. R is 3. If you're trying to determine whether or not it is, that's not enough. You'd have to do at least the next one to see if you're also multiplying by 3, right? And then if you are, if you can, test a few of them, then it's geometric and your ratio is 3. Does that make sense to you? You can't just do one and say, oh, I could multiply by 3 and say, oh, it has to be geometric. In this case, we don't have to test more than one because it does just say that. I just want to make sure I make that point here. So we get that R is equal to 3. Then we're also supposed to find the next 3 terms. So go ahead and do that and tell me you have a calculator, or at least you should. It should be easy. This is the calculator isn't required to be able to do this, but it does definitely make it easier. Right. So in this case, no fancy formula is required. You could just literally multiply by 3 because there's not that much that you have to find. We all good? All right, y'all do number 2. Find R and then find the next 3 terms. So that's what I got. And if your signs alternate, then you know R is going to have to be negative because it's going to change it every time. Okay. Any questions at this point? All right. Now remember, there's 2 different kinds of formulas you can come up with, a recursive and an explicit. The recursive formula is where you can just pretty much describe what's happening like, oh, I'm taking the term before it and I'm multiplying it by 3, right? But if I want the 50th term, I'm going to have to find terms 1 through 49 before I can actually get there, right? And I have to write them all out. That's recursive. But then an explicit formula means I should be able to just substitute 50 in and find the 50th term. So we had one for an arithmetic sequence. We have one for geometric as well. So the nth term of any geometric sequence can be found using this formula. an is equal to a1 times r to the n minus 1 power, where a is still the first term and R is the common ratio. So by using that, yes? RB, is that what I put? Negative 1/4. Because you're multiplying by negative 1/4 every time. You're dividing by 4, but we don't talk about things as division. It's the ratio. When you take 128 and put it over 512, you get a negative 1/4, and then each term gets multiplied by a negative 1/4. Does that make sense? Anything else? All right. So let's look at, let's see, we're going to start with number 6. So we're going to write an explicit formula using this right here that we have, and then we're also going to find A8. So in order to find that, we have to know A1. Well, A1 is negative 2400. Then we also need R. And in this case, we know they're geometric, so we don't have to test them. We just have to find what R is. So R would be positive because the signs stay the same, right? A positive what? 1/2. Okay. So there's R. So then my explicit formula is going to be AN is equal to A1, which is negative 2400, times 1/2, which is in parentheses. Otherwise, my exponent looks like it's only going to the numerator, to the n minus 1 power. Then I have to find A8. So instead of like listing out all the terms, A8 is just going to be equal to negative 2400 times 1/2 to the 8 minus 1 power. And I've already been asked, and I'm sure I'll be asked all day, could you just put 7 here? Yes. I'm not going to, though, because I don't want you to get confused about where the numbers are coming from, but you could also write it like that and just type in 7, like it doesn't matter. But let me ask you a little side note question here. This is a negative 2400. If this was a negative 1/2, would those signs cancel each other out? No, because of the exponent, right? So don't go making weird stuff up, right? So go ahead and type that in. Figure out what A8 is. I got negative 75/4. And you're going to give a fraction unless there's a decimal in the sequence itself. Okay. What questions do you have? All right, y'all do number 7. 7. This one. It's right there, little X. You don't need to do the little triangle. Hit that X with the little box.
Oh,
That, yeah, hit that, and it'll put the little box up there for you. There you go. Yes, yeah. So if it was number 3, then you're in it. You got a decimal answer, then you would use a decimal. That's kind of the common practice. All right, so reading the directions correctly is important, right? Because this one said write an explicit rule and find A8. So my explicit rule is in green, and then my A8 is in pink, right? So you have to have, there's 2 parts to that answer there. All right, does everybody agree with my answer? Do we have any questions? All right, flip it over. And then I'm going to rewrite this. So we have AN equals A1 times R to the n minus 1 power. And we're going to skip down to, let's see, number 11. We're going to do more of these than we did on the front because there's something a little bit different that happens in some of these. So it says use the information given to find the indicated value. So here it's not asking me for AN, so I don't have to like write in the actual rule, I just need to use the rule. So in order for me to find A6 in number 11, I need A1 and R to be able to use this. Well, I've got all that stuff. So A6 is just equal to A1, which is 240, times R, which is a -2, to the 6 minus 1 power. So this is just kind of a plug and chug problem, but you got to know how to put it into the little formula. Let's go ahead and come up with that value. Okay, get -7,680. All right, so let's look at 12. That one's hopefully fairly simple. It's almost exactly like what we did on the front. On number 12, they give me A2 and R, but I'm looking for A10. In order for me to use that explicit formula over there, what do I need that I don't have? A1, but I can find it. So the first thing I'm going to do is use these two pieces of information to come up with A1. So I know that A2, which is -8, is equal to A1, which I don't know, times R, which is 4, to the n minus 1 power. Well, here n is 2, so it's 2 minus 1. Oh, I put R instead of 4. Dang it. Sorry. R is 4. I know what it is, so I should put it in. 4 to the n minus 1, that 2 minus 1 right there. So 2 minus 1 is... It's 1. It's all good. I know this is getting really complicated. So we get 4 there, and we divide. So A1 is equal to -2. All those tricky questions I ask. Okay. A1 is equal to -2. It's all good. I see things like that all the time. So now that I have that, and then I've got, so now I have what A1 is. I no longer need A2. I'm looking for A10. It's equal to A1, which is a -2, times R, which is 4, to the 10 minus 1 power. So there I had to find something that I needed so that I could get what I'm actually looking for. That's what we should get. All right. Questions? All right, y'all do 13 then. Man. Thank you. Better finish these notes on your own. Okay. Mm-hmm. Your time is 9:15, so you have to. Huh? It's, well, that says 9:15. It's 9:13 right now, so you got 2 minutes, I guess, to get there. Yeah. All right, what questions do you have? We good? All right, let's look at 15. 15, it gives me A1, gives me A6. I need A12. What do I not have that I need? R, but I have enough information to find it. So I'm going to use these two to find R. So I've got 486, which is A6, equals A1, which is 2, times R, which we don't know, to the, and this right now is in, 6 minus 1 power. So if I divide, I'm going to get 243 is equal to R to the 5th power. So how do I undo something to the 5th power? The 5th root, right? So R is going to be equal to the 5th root of 243. Bless you. So on your calculator, right below the replay, the big oval button, there's a little, looks like a square root, but it's got 2 boxes. It looks kind of like this. So you have to do shift and then get that little thing to pop up. And then once you do, you put your 5 here and your 243 there. And you should get that R equals 3. I know, that's why these are so amazing. And by the way, I was at Walmart the other day. They have these in stock at Walmart. They're $18, but they do have them on Amazon for 12 something still. So the price seems to keep going up. They are in Prime for 12 bucks. You can find, but when you look for them, they pop up a couple times, and one of them it is 8. You know, sometimes you see the same thing over and over again. One of them is 18, but there's one, at least the other day when I looked, Amazon changes hourly, but it was still 12. I know, I think so too. I think after because when I bought my first one like a year and a half ago just for myself, it was like $8, and then it just keeps going up. So I guess I drove the prices up all by myself. All right, so now I have R is 3. I'm looking for 12, so A12 is equal to A1, which is 2, times R, which is 3, to the 12 minus 1 power. Sorry, 354,294. Okay, everybody okay with that? All right, so now we're going to look at 16, because 16 is even a little bit different than that. On 16, I have A4 and A7, and I'm looking for A2. So I don't have A1 or R. I need both of them. And so what you can do is you can basically use A4 or A7, it doesn't really matter, but I'm going to use A4 and pretend like it's A1. So if I'm going to pretend like it's A1, then that means 4 really becomes 1. Does that make sense? But like 4 doesn't really equal 1 numerically, but we just have to think about it that way. So when we're substituting it into our little formula over here, A7, which is negative 75 over 128, would be equal to A1, but we're using A4 as A1, so that's 75 over 2, times R, which we don't know, to the n, which is 7, it's the n minus 1 power, but what is 1 now? 4. So this is really the 7 minus 4 power. We're kind of like chopping off the beginning of the sequence to just use this because it should have the same R, right? So because it was n minus 1 and 1 is now 4, that's why we have 7 minus 4. Everybody okay with that? Yes? Okay. So then that means I get negative 1 over 64 is equal to R cubed, and R is equal to negative 1/4. All right, so I could go find A1, but I really don't need to because I can still pretend. Pretending is fine as long as I'm doing it accurately, all right? So now I'm looking for A2. Well, A2 is equal to A1, but we've substituted it for A4, 75 over 2, times R, which is negative 1/4, to the n, which is 2, minus 1 power, but instead of 1, we are using 4, which will give me a negative exponent, but that's fine. It'll work out. That's kind of the whole purpose. So I can just type all that in and get my second term here. Why do you use 4? Because I don't have, so like if I had these terms, you know, whatever they are, I'm going to make up numbers here, but like if I had a sequence and it was, I don't know, let's just do 2, 4, 8, 16, 32, 64, blah, 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 right? So if I had this, now my A1 is 2, right? But if I'm looking for R and all I have is like these two numbers maybe and I'm trying to figure out what's going on, basically I'm just like chopping off the beginning of this so I can use this as A1 and then figuring it out that way because I didn't have R or A1. Does that make sense? So in theory, this is kind of what we're doing, is just chopping it off and pretending now that this is A1 instead of A4. But I still have to use the 4 for it all to make sense since this is 7. Either that, or I could change both of them. I could change the 4 to 1, and I could change the 7 to what, 4, something like that. But either way, we're good? It's a good question. So we should get 600? Yes? All right, good deal. All right, so let's look at explicit versus recursive formulas for each sequence. So remember that your recursive formula is the one where you're just kind of describing the pattern. So if you're going to look up here, you could tell me what's happening here. Times -5. So I'm multiplying by -5. I'm multiplying by -5, right? So with the recursive, you have to identify the first term, at least the first term. A1 is 2. Then I can say that AN is equal to -5 times A times n, or to the A sub n minus 1. Because basically this means whatever term I'm looking for, I take the term before it, multiply it by a -5. That's what that's saying. Then, since I've identified what A1 is, if I substitute a 1 in for n, I get 1 minus 1 right here, which is 0, which makes no sense. So this only works when n is greater than or equal to 2. There's my recursive. By just being able to describe what's happening here, I have come up with R. R is -5. Now, if you can't just look at the numbers and know, because sometimes you can't, then -10 divided by 2 is 5. That's where you get your R, right? So then your explicit formula is AN equals A1, which is 2, times R, which is -5, to the n minus 1 power. Explicit allows you to substitute in any n. Recursive means you have to know the terms before it. Okay? Y'all do 18. Make sure you understand the difference between recursive and explicit. Should be fairly simple here. So when you're done, if you agree with me, then grab your other piece of paper. If not, ask me questions. If you identify A1, then you have to start with 2. Because if I substitute in 1 right here, then 1 minus 1 is 0, and A sub 0 doesn't exist. Does that make sense? And on some of the arithmetic ones, you had to identify A1 and A2, and then n would have to be greater than or equal to 3. Thank you. All right, grab your other one. And this one is going on 151. So we talked about arithmetic means yesterday. Remember, mean means average. You've done that for a long time, but it's the average of any, you take two, for the arithmetic anyway, and this is not arithmetic, these two terms, you would average it to get this one on any of those arithmetic sequences. That's not what's happening here. These are geometric means. So the geometric means are the terms between any two non-consecutive terms in a geometric sequence. So, for example, we're given this sequence. The geometric means between 3 and 243 are 9, 27, and 81. That's what it means of what they are. We are going to start by doing number 19. So I have these terms, -4 and -2500. And I don't know if this is A1, I don't know A whatever, but we're going to use it as A1. So this is -4, and then I need 3 numbers, and then I would get -2500. So in this particular case, I'm using A1 to be -4, and I'm using 1, 2, 3, 4, 5, A5 to be -2500. What is it that I need to find? R. So -2500, which is AN, basically, is equal to A1, which is -4, times R to the 5 minus 1 power. So then this will give me 625 is equal to R to the 4th. So I can figure out what R is. The 4th root of 625 is what? 4th root, you can also take the square root and square it again. Square root of 625 is 25. Square root of 25 is 5. So R is 5. So I don't have to write a formula for this because I only want those 3 terms. It's really easy to say, all right, well, 5 times a -4 is a -20. -20 times 5 is a -100. -100 times 5 is a -500, and I'm done. We good? All right, you do 22. You don't have to, because it's not really a set of numbers. It's kind of a, it's a good question. It wouldn't be wrong if you put them there, though. Oops. All right, any questions about what I got? We agree? Hopefully. Okay. All right, let's look at 23. It says, in 2009, Eva purchased a new truck. Oh my gosh, you're killing me. Eva purchased a new truck for $45,000. Each year, the value of the truck depreciates at a rate of 18%. Use a geometric sequence formula to find the value of Eva's truck in 2017. All right, so it's telling me flat out to use a geometric sequence. So I need things like A1. What's A1? 45,000. Oh, it would help if I put a 5 in there. 45,000. I need R. So the truck depreciates at a rate of 18%. So what's R? 0.82. Okay, it's not 0.18 because it's 18% that's going to be subtracted. So you could think of it as 1 minus 0.18, but either way, it's 0.82. This is going to have to be less than 1 if it's depreciating. Okay. And then I need N. What is N? N is not 8. because you are starting 2009, it has a value, right? So you got 2009, 10, 11, 12, 13, 14, 15, 16, 17. So you're going to take 2017 minus 2009 plus 1. You always have to take the biggest minus the smallest and add 1 back to it. You don't have to do that for your birthday because basically your whole first year of life, you're not 1, you're 0. Does that make sense? But when you use that as, when you actually count it as a year, that's different. So he's 0 years old. Well, that's better than he's 38 months old. All right, so n is equal to 9. So once you've got that, it's just plug and chug. So A9 is going to be equal to 45,000 times R, which is 0.82, to the 9 minus 1 power. This is very similar to the exponential log problems that we had, and we had specific formulas for the rates, and it included like a 1 minus R type thing. Or 1 plus R, I'm sorry, 1 plus R. But this is, basically the same thing. You just talk about it as a geometric sequence. So once you type it all in, what is the truck worth? Not $10, no. You are wrong. Oh, you said 2? It's not $2 either, I'm sorry. And it's money, so even though it doesn't say to the nearest hundredth, that's what makes sense, right? Yep. Okay. Thank you. Okay. Oh, got it. I was trying to find the name of the person. All right, so Garrett signed a new cell phone contract in 2014. The table to the left shows his average monthly bill in 2014, 15, and 16. If this pattern continues, use a geometric sequence formula to find his average monthly bill in 2025. All right, so A1. And this may not be the first year of his contract, but this is the first year that we can see. That's why it's A1. And that is 75. Then R, how do I figure out R? The other way, yeah. 76.5 divided by 75, and that gives you what? 1.02. Okay. Then I need N. What is N here? 12, because it'd be 2025 minus 2014 plus 1. So N is 12. All right, so you finish that one up while I hand out the assignment. What? Got $93.25. Yes. All right. What questions you got? Anything? Nope.